All right, so second to last section we're going to take a look at this week is 7.3. It's on different properties of logs. So we're going to learn a few more formulas that we can use to simplify logarithms. And we're also going to look at how we can take logarithms that are separate and combine them together. But you can only combine logarithms if they're kind of like terms. Okay, so we'll learn what that means. So these four properties that I'm about to give you, they're not really anything mathematical that we have to calculate. They're more of a special pattern to look for. And if you see this pattern, something nice always happens, and we can get the answer very easy. Here is the first one. If you have a problem that fits this pattern, okay, it's kind of a unique pattern, but with numbers it would look something like this. Let's say 5 raised to the log base 5 of, let's make up a number, 8. Because these two 5s are the same, what's going to end up happening is this part basically cancels itself out. That only works because those two numbers are the same. And all that's left is that. And that is the answer to the problem. All right. I can show you that as an example by typing it in. Oops. Log base 10 is one of the bases the calculator can do automatically. But I can do other bases on a graphing calculator, so let me type that problem in. 5 raised to, let's see, log base 5 of 8. And I'll hit enter. And so you can see it. I typed in 5 raised to the log base 5 of 8, and it gave me an answer of 8. If those 5s weren't the same, that pattern wouldn't work. So, this is a raised to the log base a of m. So, what do you think is right there under the equal sign? Yeah, Pete? M. The answer to a problem like that is whatever number is sitting right there, because the other part cancels itself out. That's it. Just a special pattern that can come up sometimes. Any question on that one? All right, let's look at another special pattern that can come up. Log base a of a to the r. Well, let's try it with numbers and see what happens. The key though is with this pattern, these two numbers have to match. So let's do like log base 4 of 4, and I'll pick a power for r. It could be anything. Let's do log base 4 of 4 raised to the, and now we have to pick an exponent. Autumn, can you give me an exponent? 3. So let's put in 3. Hit enter. And look at what you get. Log base 4 of 4 to the third. Kind of the same idea as the last problem. These two things cancel each other out. And the answer that you end up getting is whatever the exponent was. Just a special pattern. So, log base a of a to the r. What do you think is under the equal sign? Or under the screen this time? Yeah? R. Yep. So the answer to that problem is R. Now, is number 2, look at the whole equation, is that an equation that's in log form or exponential form? That's log form. Something here, and something here. Let's change it to exponential form. And it will show you why this formula is true. Okay, this is the formula. What I'm going to write over here is the reason why it works. What is my base in this one? Or just tell me, because there's a lot of letters here that are the same, tell me what color box it's in, the base. Yep.
Red.
Yep, the red box. That's my base. All right. Logarithm always equals what kind of number? Yep.
The exponent.
The exponent. So there's the blue box. And the green box, what do we call that? That's the thing we're plugging into the logarithm. That's my argument. And where does that end up?
By itself.
All by itself on the other side. Look at what we just got. A to the power of r equals a to the power of r. Is that true? Yeah, of course it's true. What rule 2 is basically saying is that something is always equal to itself. Well, yeah, 5 always equals 5, 3 always equals 3. Something always equals itself. This is how you would see the rule in Algebra 1. This is how we can write the same rule using a logarithm, but it's the exact same thing. Let's look at property 3. Property 3 says if you take the log of 1, the answer is always 0. It doesn't matter what base. Base 2, base 5, base 6, base 13, doesn't matter. Anytime you take the log of 1, the answer is 0. All right. Let's look at this one and see why this one's true. How about Colby? Is this an equation in log form or exponential?
Log.
It is log form again. We've got that. We've got that. And we've got that. Jacob, what's my base here?
A.
Yep. This time there's only one A, so there's no confusion which one he's talking about. It's the one in the red box. A is my base. How about 8 in logarithm? Always equals what kind of number?
Exponent.
Yep, exponent. So the 0 is my exponent. And the last thing is the box in green. And Angelina, what do we call the box in green?
The argument.
It's the argument, and it ends up by itself. This rule 3 is basically saying if you raise anything to the 0 power, you get 1. Of course, that's a rule from algebra. Anything raised to the 0 power is always 1. 5 to the 0 power, 1. 9 to the 0 power, 1. 42 to the 0 power. What do you think? 1. Anything to the 0 power always comes out to 1. That's how you see in Algebra 1. That's how we can write the same idea with a logarithm. In Rule 4, you're going to recognize that one from the homework. We had, I think it was a problem in the homework that said this. Log base 8 of 8. And we had to figure out what it was. And the way we figured it out in the homework, we said, well, we don't know what it's going to equal, so we'll just set it equal to x. 8 is my base. X is my exponent. And the 8 ends up on the other side. And then I asked you, what power can you raise something to so you get the same thing back? And the answer was 1. Well, anytime that you take a log and the base and the argument match, like an 8 and an 8, or a 12 and a 12, anytime they match, it doesn't matter what they are. If it's 8s, 12s, 2s, the answer is always 1. Right, and let's change that from log form to exponential, and it'll be a very simple reason why it's true. Okay, so again, this is the formula. On the right, I'm just putting down the reason why it works. All right, so we've got base, that, and that. So James, what's my base here?
The red one.
The red one, yep. Red box, it's A. That's my base. Lacy logarithm always equals what kind of number?
Exponent.
Yeah, always equals the exponent. Good. And the only thing I haven't used is my box in green. That's what I'm plugging into the log. And Cassidy, what's green box called?
Argument.
That's my argument. And it ends up on the other side. So, the reason why this property is true is because if you raise anything to the first power, you get the same thing back. That's what that property is saying. Anything to the first power gives you back what you started with. Of course. Yeah. All right. So let's try a few problems where I fill in some numbers in those formulas. So we'll try to identify which property it is, 1 through 4, and then use that property to simplify what we have. Okay, I can put the properties on the screen, but it's going to look a little bit small. So I'll read it off. So example 1a says 2 raised to the log base 2 of pi. Okay, what property does that one look like? Does that look like property 1, 2, 3, or 4? Yeah.
1.
Yeah, that is property 1, where you have a logarithm in the exponent, and the base on the log matches the base on your exponent. So, based on that being property 1, anybody think they know what the answer is going to be? Yep. Pi. The answer is whatever the exponent in the problem, or not the exponent, the answer is whatever this is right here. Pi. And that's it. Okay, so it's just a special pattern. Okay, example B. Log base 0.2 of 0.2 to the negative 4th power. Okay, which property does that one look like? Yep, Vivian?
Second one.
Yeah, that's the second one. Properties 2, 3, and 4 all start with the word log. So this starts with the word log, so we know it's one of those. And the base on the log and the base on the argument are the same. So in this case, the A is 0.2. So Mateo, what do you think that is going to come out to?
Don't you need it? Oh, wait. No. 0.2.
So when we simplify that, that's the answer right here, right? The R.
Yeah.
Where is the R? What's the R in this problem? What's taking the place of the R? Like if you were to literally drag this right on top of it, what number would land on top of the R?
I was trying to find it, but there's nothing on the right of the equal sign, right?
Well, that's what I'm asking you. What should go right there? What's there in property 2?
There's
What letter?
A.
But that's on the left side of the equal sign. We're looking for what's on the right.
R.
R. So where is my R in this?
The exponent. So negative 4.
Negative 4. Good. Okay, so the answer here is R. So we just have to look, okay, what's the R in my problem? And that's a negative 4. Any questions on that one? All right, let's look at this one. The ln of e to the kt. A little bit tricky, but that is one of the properties on the left. Anyone think they know which property that one is? What?
2.
It is property 2. How can we rewrite this to make that a little more obvious? What's the long way to write out ln? Got it? Log, what else? Yeah. Log, how do you say it? What's the e? It's going to be my
The base.
base, so log base e. That takes the place of what I just circled, log base e. Now copy down the rest of the problem. Put the argument, e to the kt. Now we can see we have a log where these two things match. So that is property 2. So in this case, what would my answer be? Yep.
KT?
KT, whatever K times T is. All right, and let's do one more of those. Let's do log base 12 of 12. What would that simplify to? Log base 12 of 12. Yep. 1. Whenever the argument and the base match, the answer to a logarithm is always 1. Okay. Any questions on those 4 properties? Okay. So let's take a look at some properties we can use to either take logs that are separate and combine them together, or we can take logs that are already combined them together and we can split them apart or separate them apart. Let's start out with this first property. The first property here has to do with the logarithm of a product, multiplying two things together. If you have the logarithm of a product, what you are allowed to do with that, if you want to separate it into 2 logarithms, you can. So you can write log and log. The base on the original problem has to be the same base when you split it up. So the base stays the same the whole time. A, and A. If you have multiplication between 2 things in the argument, when you separate it, you put a plus sign. That's how it splits up. Multiplication turns into a plus sign. My first argument becomes the first factor, and my second argument comes from the second factor. And if I had a third argument, like let's say I had m times n times x, well, then I could put plus, and then I could do another one. Okay, so you can separate as many things as you have here as long as they're all multiplied together. And that's an example with numbers. All right, let's try it. So that's log base A. Again, the base can be anything. It just has to be the same for the whole problem. The easiest base for me to show you on the calculator is base 10, because the calculator has a button for it. I can do other bases, but base 10 is easier. So let's take the log of 4 times 5, which really is just the log of 20. Same thing. Now let's take log 4 plus log 5. And I get exactly the same thing. What's another way that you can multiply two numbers and get 20 besides 4 times 5? Yep.
Number 2.
You could also split this up into a 10 and a 2. Instead of doing 4 times 5, let's say we did 10 times 2. That would be log 10 plus log 2. There you go. Comes out exactly the same. So the point is, you can always split multiplication up as a sum of two logarithms. Next thing we're going to look at is when we have a fraction. Multiplication turns into a sum. What do you think a fraction would turn into? Anyone have a guess? Yeah?
Is it subtracted?
It is. It's subtracted. And it is subtracted in a certain order. So it splits up into two logarithms. Each log has exactly the same base as the original problem. The numerator is your first argument. The denominator becomes your second argument. And you put a subtraction sign between them. Okay, and here's an example with numbers. I'm not going to type that one in, but you could check it. And you could see it works. And that's property 2. Any questions on the first two? All right, now we're going to look at one more. In the last property, it's kind of like example 1. Kind of like example 1. But instead of having two different letters, we're going to have two letters that are the same. Let's look at an example, and then we'll write down property 3. Say we had log base 4 of x times x. And I want to split that up. Actually, you know what? Even let's write it. Let me start like this. X times x is x squared. And I want you to focus on where that 2 is right now. And then I want you to look at where the 2 ends up in the final answer. So we can think of x squared the way I had written it the first time. X squared means to multiply x times x. I have multiplication inside the argument. We can split that up into two logarithms. Log and log. And using property 1, what's going to be the base on each of those logs? Yep, 4. The base stays exactly the same as what it was originally. And when we have multiplication between logs, what sign do we put? Is that addition or subtraction? Johnny?
Addition.
Addition. My first argument is the first letter. My second argument is the second letter. So I have log base 4 of x plus another log base 4 of x. How many log base 4 of x's is that? 2. I have 2 log base 4 of the x's. So I asked you to focus on one specific thing. I asked you to look at where the 2 was when we started and look at where it ended up. So rule 3 is a rule that allows us to take an exponent and put it in front. This is the reason why you can do that. Okay, we're not going to go through these steps every time. We're just going to be able to use this property from now on. Anytime you have an exponent on a log, you can move it to the front, just like that. So the r is an exponent, and I can take the r and put it down in front. There's an example with numbers. So all of these properties that we just went over, all three of them, they all work for any base. It doesn't matter if it's a base 10, if it's a base 4, it can even be a base e, in which case we'd be writing ln. We use the abbreviation. It works for any base. Any questions on that third property? All right, and there is one more thing we have to remember from algebra. And it has to do with another way that you can write a square root of x. Does anybody remember what power you can use? And it means the same thing as taking a square root. Like I could raise 9 to a certain power, and it would be the exact same thing as doing that. Anybody remember what power could go in that box? Yeah? It's a half. Anything raised to the 1/2 power means to take the square root of it. And the reason why that's important is because let's say you had a problem like this. And you wrote that as a final answer. And I said to you, when you write your final answer, do not leave any exponents in the answer. And you might look at this and say, okay, well I did that. I didn't leave any exponents in that answer. Yes, you did. You did leave an exponent in the answer. Okay? It's hidden. Bless you.
Thank you.
It's hidden by that square root. Square root of x really means x to the 1/2 power. So what you really wrote is that. You hid the exponent, but that doesn't mean it isn't there just because you hid it in the square root symbol. So anytime you see a square root of x, think of it as x to the 1/2 power, and then think of rule 3. You can take that 1/2 and put it in front. So it really, bless you, becomes that. What's in those two boxes are exactly the same thing. One has an exponent in the final answer, hidden. The other one doesn't. You've moved it to the front. And we'll do a problem where that comes up. But that's always something that people get tripped up with on the test. They'll leave a final answer with a square root and it says not to. All right. So let's try to see if we can take a single log and split it up into 2. And you might be wondering, well, wait, where does it say what he just said about not leaving exponents in the final answer? It says it right here. It says express powers as factors. That means do not leave something as a power. Put it in front. When it's in front, it's called a factor. Jade, you got a question?
I was just going to ask if that would be specified on the test or if it's just like implied.
Nope, it will specifically say it in the directions exactly like that. Express powers as factors. Which again means move the exponent into the front of the problem. All right, so log base 4 of 3x. Okay, so let's split that up into 2 logs. Ben, when I split that up into 2 logs, what's going to be the base on each one of them? 4. It's going to be the same as the original base. We have multiplication inside the argument. 3 times x. What's going to be the symbol between those 2 logs right now? Yep, we're going to do a plus because multiplication turns into addition. James, what's going to be my first argument?
3.
3. And my second argument?
X.
x. And that's it. That's how you separate two logs, or you separate one log into two. I just wanted to see something. Any questions on that one? Yes.
Don't you have to get rid of the exponent?
Where's the
Does it
exponent?
express all power of the factors, lost one from the thing?
Where do you see an exponent?
Would the 3 and the x be the exponent?
No, those are arguments.
Okay.
Exponent would be up here. Remember, if this was line paper, the 4 and the other 4 are subscripts. Everything else is right on the line. If I had a number like a 5 here, then yes, I would have to put that 5 in front. But I don't. So that's the final answer. All right, let's try this one. Log base 2 of 5 times r cubed. All right, so Lacey, what operation am I doing between the 5 and the r cubed?
Aren't you just multiplying?
Yeah, we're multiplying 5 times r cubed. And when we have multiplication, what symbol does that turn into when we split up our logs?
Wouldn't it be a root?
What is it?
Wouldn't it be a square root?
So first I'm asking what I'm going to do with these two logs. The choice is add or subtract.
Add?
Yeah, we're going to add, right? Multiplication turns into addition. Jacob, what's the base on each log? Well, what was it originally?
2.
2. So let's keep it the same. So was it 2? It stays at 2. The base doesn't change for the whole problem. All right, Cassidy, what's going to be my first argument?
5.
A 5. And what's my second argument?
R.
What is it?
R.
What else goes with it? R would be just this.
Oh, R3.
R, yep, R to the third. Okay. Is that okay? We split it up into two logs. We did the first thing they said, right? As a sum or difference. We did it as a sum. What haven't we done? Yep.
We have to move the exponent.
We didn't move the power. We didn't put the power in front. So where's that power going to go then?
In front of log 2r.
Yep. It's going to go, I'm just going to make a little space here. I'm going to put the 3 in front. Just so I don't have to rewrite the whole problem again. If you want to write it a second time so you can see each step, you could do it that way. But that's the final answer. Okay. Any question on that one? All right, so we did a couple with multiplication. Let's try this one. Log base 9 of x divided by 2. Okay, that's going to split up into two logs. Jacob, what's going to be the base on each log?
9.
9. I'm going to keep the base exactly the same. Yep.
Does it always split them into logs?
It depends on how complicated the argument is. If you had something like this, that would actually split into 3 logs.
Okay.
Because now we have multiplication will split and we have division. So,
For everything that we're doing, is just 2 or
yeah, I think most of them are going to split into 2. If we hit one with 3, we are going to combine one with 3.
okay.
We are going to do that. Okay, what operation goes between my two logs? Yep,
Subtraction.
we're going to subtract them because we had division. if you accidentally put addition, it's wrong. Okay, you gotta do subtraction. And what is, how about autumn? What's my first argument?
X.
X, and my second argument? 2. And we're done. Questions on that? Yes?
If you were to put the 2 on the left and the X on the right, would that be wrong? Or is it like the same?
Yeah, that one would be wrong because subtraction, the order does make a difference. That would be the difference between if you ask, like, if you do 3 minus 5 and do 5 minus 3, is it the
But
same?
The addition ones, it doesn't matter?
Yeah, addition doesn't matter because you can do 3 plus 2 or 2 plus 3. You can always switch the order when you add, but you can't switch it when you subtract. Numerator first, denominator second. Yep. All right, and let's do this one. Okay, even though this one says ln is just a log with a base of e. So we did log base 9, we did log base 2, we did log base 4. Now we're doing log base e. You don't have to write it as log base e. Use the abbreviation ln. Okay, anyone think they could do that whole problem and give me the final answer following everything it says to do in the directions? John?
Log base E.
Let's use the abbreviation. Yep.
ln y to the third minus ln e.
All right, so I like the minus because we had division, so we definitely want to use the minus. But there is one more thing we have to do. And see the other thing, Vivian?
Do you move the exponent?
Yes, that 3 is an exponent. Okay, that has to be moved. Can you tell me where?
Onto the beginning.
Yeah, it goes in front of the term that it came from. So it came from the lny term, put it in front. And that would be the final answer. Okay, so any questions on splitting logs apart? Now, recombining them is pretty much the same thing, except in reverse. The first thing we're going to do when we recombine is if you have a number in front, put it back as the exponent. And then look at the operation between the two, and that'll tell you if it should be division here or if it should be multiplication. All right, so let's share. Recombine. So it says combine the following into a single log. Now, they didn't tell you the base. This time they just said the base is A. That's fine. Just keep the base A. If you don't know what it is, use whatever it is they tell you to use. So, what would be the first thing that I would do here? Just think of what we just did, but now do it in reverse. Yep.
Put the 4 as an exponent on the 3.
We're going to put the 4 back as an exponent on the 3. Yep. So log base A of 7, that's just going to stay the same for now, plus log base A of 3 to the 4th. Now, anybody see something there that I could do out with my calculator before I keep going? Yeah?
3 to the 4th.
I should do 3 to the 4th, and that's 81. So let's write that as 81. Log base A of 7 plus log base A of 81. Now we're ready to combine this into a single log. What's going to be my base when I recombine it? Yep.
A.
Yep, base is going to be A. And what am I going to do with the 7 and the 81? Look at what I'm doing here and think what that would have come from. Yep. We're going to multiply them. 7 times 81. 7 times 8 is 56. 7 times 1 is 7. That's 567. You could use a calculator if you need to. That's and there's your answer. Log base A of 567. Alright, let's try this one. Just move that down a little bit. I'll move that. Right, let's see if we can do this one in one step. I'm going to have a log. Ava, what's going to be my base on the log?
3.
3. It's going to be the same as the base originally was. So it's going to be a 3. And inside the argument, are we going to multiply or are we going to divide? Okay?
Divide.
Yeah, we're going to divide. What told you it was division?
The minus.
Yeah, think of this minus almost like a fraction bar, right? The minus, it's like what you put right in the middle of a fraction. So we're going to divide. What's going to be my numerator? Yep.
V.
What is it?
V.
V is my denominator. Because remember, V comes second.
U squared.
U squared. 2 goes back as an exponent. And whatever's subtracting, whatever's at the end, that must have been the denominator. So it's log base 3 of u squared over v. Okay, any question on that one? All right. Let's try, I think that's good for that part. So any questions on combining or splitting in general? All right, so the last thing is the change of base formula. So this is a formula that we use on the calculator. So this part is all done on a calculator. There's only 2 bases that we can do on the calculator. The calculator only has 2 buttons. Does anybody remember one of the bases we can do on the calculator? Yeah? We can do base 10 by pressing the button next to the 7 that says log. What's the other base that the calculator can do? Yep. Eat. And we can do that by pressing the LN button right by the 4. Other than base 10 and base E, there is no button directly for doing any other base. Doesn't mean you can't type it in. There's just no button for it. So, the change of base formula allows you to change the base on a logarithm problem to either a 10 or an E. Why would you want to do that? Because you have buttons on the calculator to type that in. And there's 2 ways to do the change of base formula. I'll show you both. I would just pick one of them to remember because either one of them works just as good as the other one. And they're both exactly the same amount of difficulty to type in on the calculator. Once you copy that. Generally, with these kind of problems, I think on the test, it's going to ask you to round to 3 decimal places. So just make sure that we round properly to 3 decimal places. All right, so here's the change of base formula. Let's say that you had to do log base A of m. The only restriction on A and M is they're not negative. I mentioned yesterday, it can't be a negative. If they are, then we're doing imaginaries. So A and M will never be negative. The way you can type this in on a calculator is like this. Log of the argument divided by log of the base. And if you forget which one goes where, look at where they are in the original problem. the A is lower than the M because it's the base. The A goes on the bottom of the M. Now, I didn't put a base here. I just wrote log. What base am I assuming if I don't put a base? Yep.
And
That's base 10. That's the common log. Take the common log of the argument and divide by the common log of the base. Or, take the natural log of the argument and divide by the natural log of the base. It will come out exactly the same. I would pick one of these two ways to remember how to do it. I wouldn't try to remember both. Let's try a couple examples with numbers. Log base 5 of 12. Do I have a button for base 5 on the calculator? No. If I did, then I'd be done. I don't have a button for base 5. So I need to turn it into a fraction. Can somebody tell me one way that I can rewrite that so I can type it in on the calculator? Yep, Judy?
Log 12 over log 5.
Yes. Log 12 over log 5. And now we have to type that in. So notice when you press the log button, it not only does log, but it puts a parenthesis. You need to close that parenthesis when you're done with the first log. Put in a 12, and I'm done with the top. So close that parenthesis to let the calculator know. Divided by log 5, and then close the parenthesis to let it know you're done with the bottom. Okay, enter. And we get 1.54 if we round it properly. On the test, the directions will tell you how many decimal places to use. Now, instead of doing log, we could have done ln. ln 12 divided by ln 5, you get exactly the same thing. So it doesn't matter which way you do it. And all scientific calculators will have both a log and an ln button. I've never seen a calculator that has one and not the other. So. All right, so that's that one. And let's try this one. Log base 3 of 16. Now, let's pretend for a second we don't know what it is. This is what you're really figuring out. You're figuring out 3 is my base. Logarithm always equals what kind of number? The exponent. And the argument ends up by itself on the other side. You are really solving this equation. You're figuring out what power would you raise 3 to get 16. And that wouldn't be easy to do by hand. If you try 3 to the second power, that's 9, too small. 3 to the third power, 27, too big. So the answer here is somewhere between 2 and 3. What's the exact answer? Well, let's see. How would I rewrite that so I can type it in? What?
ln 16 over ln 3.
ln 16 over ln 3. Let's try it. Close the parenthesis because I'm done with the 16. Make sure you put divided by. And close it because I'm done with the 3. I get 2.524. Let's try it. Let's raise 3 to the 2.524 power and see if we get 16. 2.524. Well, how come I got 16.005? It's close to 16, but that's not 16. Yep.
Because you rounded up.
Yeah, I rounded. That's not the exact answer. That's not the exact answer either. It's rounded off. Okay. So now you have a way to solve an equation like that. Change it to log form. and then we have to type it in using the change of base formula. Okay, any questions on change of base formula? Okay, so at this point, I've pretty much taught you all the different techniques that we need to know to solve logarithms. Tomorrow, we'll solve equations. A couple things we're going to need for tomorrow. Factoring might come up, right, from algebra 1, and quadratic formula might come up as well. So we don't spend a whole lesson relearning that, but we will go through a problem that has it in it. Okay. Alright, so homework tonight, it's on 485. 7 to 15, those are just odds. 31 to 33 is all. And then 39, 40, 51, 52. And 65 to 69 is just odds. Okay, you will need a calculator for the change of base formula problems, but any scientific calculator should be fine. Doesn't have to be a graphing calculator. Remember tomorrow, last day of new material for the week, and we'll have our test on Thursday, and I'll also be after school on Thursday as well. So if you still need extra help, you can come Thursday, and you have time to finish the test on Friday.